You wouldn't survive falling into a neutron star. In fact, that's not even the terrifying part. Because long before you ever touched its surface, long before gravity could pull you down, the neutron star would already have killed you. Its radiation would tear through your body. Its magnetic field would distort matter itself, and its gravity would turn every rule of the human world into something completely meaningless. Neutron stars are among the strangest objects in the universe. They are not planets. They are not normal stars. They are the corpses of stars that died violently, leaving behind something so extreme that even modern physics struggles to fully describe it. And if there is one place in the universe that demonstrates just how fragile human life really is, it may be the environment around a neutron star. To understand why nobody can survive near one, we first need to understand what a neutron star actually is. Everything begins with a massive star. A star many times larger than our sun spends millions of years fusing elements in its core. Hydrogen becomes helium. Helium becomes heavier elements. And eventually, the star reaches a point where fusion can no longer support its enormous weight. In a matter of seconds, gravity wins. The core collapses. The outer layers explode outward in a supernova so powerful that it can briefly outshine an entire galaxy. What remains behind is the core, but calling it a core doesn't really capture what it has become. Imagine taking more mass than our sun and compressing it into a sphere only about 20 kilometers across, a city-sized object containing hundreds of thousands of Earth's worth of mass. The result is a neutron star. 1 teaspoon of neutron star material would weigh billions of tons on Earth. A single spoonful would outweigh mountains. And yet this unimaginable object is only the beginning of the nightmare, because now we have to approach it. Let's imagine a spacecraft slowly traveling toward a neutron star. At first, nothing seems unusual. The star appears small in the distance, just another object floating in the darkness of space. But appearances are deceptive. The closer you get, the more reality itself begins to change. Gravity near a neutron star is almost beyond comprehension. On Earth, gravity accelerates falling objects at roughly 9.8 meters per second squared. Near a neutron star, gravity can be hundreds of billions of times stronger. If you somehow stood on its surface, every kilogram of your body would effectively weigh hundreds of billions of kilograms. Not even steel could support such forces. Not even atomic structures are comfortable under such conditions. And yet gravity itself is not necessarily what kills you first, because something even stranger happens. The difference in gravity between your head and your feet becomes enormous. The side of your body closer to the neutron star feels a significantly stronger pull than the side farther away. These are called tidal forces. You may have heard of them in relation to black holes. Neutron stars possess them as well. As you get closer, your body would begin stretching. Every molecule would feel slightly different gravitational forces. Every cell would experience stress. Eventually, your body would be pulled apart atom by atom. But before that happens, another killer arrives: radiation. Neutron stars are among the brightest X-ray sources in the universe. Many emit enormous quantities of high-energy radiation. Some produce powerful gamma-ray beams that sweep through space like cosmic lighthouses. A human being exposed to such radiation would not survive. The damage begins immediately. Cells are destroyed, DNA is shattered, internal organs fail. Radiation sickness would arrive rapidly. And if the exposure is strong enough, death would come within minutes or even seconds. The problem is that no realistic spacecraft shielding could completely protect humans from the most extreme neutron stars. The radiation is simply too powerful. And then it gets worse, much worse. Some neutron stars belong to an even more terrifying category: magnetars. A magnetar is a neutron star with a magnetic field so powerful that it becomes difficult to compare it to anything we experience on Earth. Earth possesses a magnetic field. The Sun possesses a magnetic field. Even Jupiter has a powerful magnetic field. But magnetars exist on an entirely different level. Their magnetic fields can be trillions of times stronger than Earth's. To understand how absurd that is, consider this. If a magnetar passed halfway between Earth and the Moon, Its magnetic field could disrupt electronics across the planet. But that is only the beginning. Move closer and the effects become far more disturbing. Atoms themselves begin to behave differently. The magnetic field becomes so intense that it can distort electron clouds around atomic nuclei. Matter itself changes shape. Chemical bonds no longer behave normally. The very structures that make life possible begin to break down. A human approaching a magnetar would not simply be injured. The atoms inside their body would experience forces unlike anything evolution ever prepared them for. Your nervous system would fail. Your molecular structure would be disrupted. The distinction between living tissue and ordinary matter would become increasingly meaningless. And yet even this isn't the most frightening aspect of neutron stars. The truly terrifying part is their surface. Because despite being composed of matter, the surface of a neutron star behaves unlike anything we know. The crust is incredibly rigid. Scientists believe it may be the strongest material in the universe. If mountains exist there, they are tiny compared to those on Earth. Not because erosion removes them, but because gravity crushes them before they can become large. A mountain on Earth can rise several kilometers high. On a neutron star, gravity allows only tiny imperfections. The strongest material imaginable is flattened beneath unimaginable weight. Now imagine trying to land there, ignoring the radiation, ignoring the magnetic field, ignoring the tidal forces. Suppose you somehow reached the surface intact. The moment you touch down, the environment would destroy you. Every atom in your body evolved under Earth's conditions. Every biological process depends on temperatures, pressures, and gravitational forces that exist here. A neutron star offers none of those things. Your body would cease functioning instantly. The concept of survival simply no longer applies. But perhaps the strangest thing about neutron stars is that they are not rare cosmic accidents. The Milky Way likely contains hundreds of millions of them. Some drift silently through space. Others spin hundreds of times every second. These rapidly rotating neutron stars are called pulsars. As they rotate, beams of radiation sweep across the cosmos. From Earth, they appear as regular pulses of light and radio waves. So regular, in fact, that when astronomers first discovered them, some briefly wondered whether they were artificial signals. Today, we know they are neutron stars. Dead stars spinning with astonishing precision. Some rotate faster than kitchen blenders, faster than jet engines, faster than almost anything humans have ever built. Imagine an object more massive than the sun completing hundreds of rotations every second. The physics involved seems almost absurd, yet nature does it effortlessly. And this raises an uncomfortable realization. The universe contains environments so extreme that human intuition completely fails. We spend our lives surrounded by conditions perfectly suited for us. Gravity that allows us to walk, an atmosphere that lets us breathe, a magnetic field that shields us, a planet that protects us from radiation. Because we experience these conditions every day, they feel normal. But they are not normal. They are incredibly rare. The moment we leave Earth's protective environment, reality becomes increasingly hostile. A trip to Mars is dangerous. The outer planets are dangerous. Interstellar space is dangerous. But neutron stars occupy an entirely different category. They are places where nature pushes matter to its limits, where gravity dominates everything, where magnetic fields become monstrous, where radiation floods the surrounding space, where the laws of physics reveal their most extreme forms. And perhaps that is why neutron stars fascinate scientists so much. Not because we hope to visit them, not because we could ever survive near them, but because they show us what the universe is capable of creating. These objects are reminders that existence is far stranger than our everyday experience suggests. Somewhere out there, countless neutron stars are spinning silently through the darkness, invisible to human eyes, emitting radiation across the galaxy, defying common sense. And if humanity ever encounters one up close, the lesson will be immediate. The universe was never designed for us. Life exists only within a very narrow set of conditions. Outside those conditions lies a cosmos of crushing gravity, lethal radiation, and forces beyond imagination. Neutron stars are among the clearest examples of that reality. They are beautiful, They are fascinating, and they are completely unforgiving. I hope you enjoyed the video, and I'll see you next time.